Is my
All right.
screen sharing mirroring? I don't know why it starts to mirror.
Yeah, I think we're good now. All right. Let's start with an introduction, Brush.
Okay. So I am Birehan Antana, a Group 43 at YSV student. I have completed my 1 year education and I had a great experience. That's all about me.
Okay, thank you, Burhan. Uh, I have posted a link to a SharePad. Go ahead to that link and check if you can edit it, and then I'll post the question.
Okay. So I can edit it. So as you can see.
Uh,
Um,
Let me just see the question.
Okay, Brooke, can you give me a minute to read and understand the question and I'll be back to you?
Sure, take your time.
And for reference, if I need something, I'll be using just a piece of white paper.
Sure, you can.
Okay, so can I ask for example? Brooke, are you
Of
with me?
course, of course. Yep. Sorry, I was muted.
Okay.
Like this, to more visible as a grid.
Yes. Okay. Brooke, are you with me?
Yes, I am. Please
So
continue.
the question says we're given an n times n zero indexed grid, and then we are standing on a cell which is being called S, and we went to rush to a D, right? S is the source and D is the destination that I want to reach, right? And then I have three kinds of cells other than the source and the destination. I have a dot if it is an empty cell, an X if the cell is stone, and an asterisk if the cells are fluid. And at each second, I can move to a cell that shares a side with your current cell, which means in my four direction I can move up, down, left, or right. Those are the sides that share with my position, and every empty cell that shares a side with fluid cell, it's gonna become fluid on every second. And then I have two problems in here. So I can't step on the stone cells because it's a stone, right? And then I can't step also into a floating cell because I will drown into it, right? So what the question right here is like my floating cell will also float on every second in its all four dimensions, which means I have in here, I have a floating cell, right? So this floating cell on the first second, the next, the side cell and then the down side cell will also become asterisk because this is gonna float, right? And then if I have another also asterisk, it's gonna also float to the next cell, right? So let's say I have D in here and I want to try to move to this point because, but at 1 second, at the first second, this also will be the first one, it's going to be also fluted, right? So I have this. So if I move to this point, it's possible, right? It's possible, but I cannot move to this one. And then next step on the first second, this gets to become asterisk, and this also gets to become asterisk. Right now this is a dot, so I can move my D into here. It's the only possible way because I can move it to here, right? And then on the next second, this also will float to this, and this also will float to this, which means this becomes asterisk. This is the second, which is I'm at the time of 2, and I can move the destination to this, right? And on the final time, okay, my output is 3, right? Which means what's the minimum time it takes to reach to the point, right? But what I'm asking is like the float is not gonna float over the source, right? The destination. Oh, my bad. I mismatched the source with the destination, so I have to trace back. I made a bit of a mistake because I am assuming this as a source. So for the first second, I can move S to here, right? This can gets to become S. This also can gets to become S, and also this can be S for the first second, and and this is going to be asterisk, and this is also going to be asterisk, right? And then moving forward on the next second, right? On the next second, right? This is good. Can I? My question is like, can I? Is the flooding will flood the source and the destination pointers, the initial source and destination pointers?
No, the flood is not going to be on the initial start or destination points.
It's not gonna flood the destination point. Yes.
Yes.
Yes. Okay. If that's the case, now it's also so now what I can do is on the next second, right? I can flute to here because this is gonna be a flute and it's gonna be this asterisk, and this S can move to here, and still there is no problem until this point, right? On the next step, this is a source, so it's gonna be not gonna be affected, which is our initial original point, but this is gonna reach to here in this pass, which is 1, 2, 3 seconds. Am I on the right track to explain the question, or have I made a mistake?
Yes, you're on the perfect track.
Okay, if that's the case, what we're gonna do is right now, we're gonna do for every second a BFS, which is level by level traversal. So for each of the keys, like what we're trying to do is like we're gonna the flute, every flute is gonna expand to its neighbors, and every source is gonna expand to an empty space, right? And then if the next neighbor of a flute is the original source destination, the source point, and the original destination point, it's not going to change it. But if that's not the case, but I am making an assumption, it's not being stated in here. If I'm making a mistake, please correct me. If the flute is going to flute this D, I'm not going to, I will never, I'm not going to reach to the destination, right? Because initially it was like this. So the flute can reach with 2 seconds to D if it is going to flute the D, but it's not, that's not the case. So on each step, what we're going to do is on every second, we're going to expand our sources and also our flutes, right? So does that make sense?
Yes.
So can I ask for time limitations, time and space limitations?
All right. Let me just check.
Okay, Brooke, are you with me? You're taking
It
much of the
is.
time.
It's 100. The size, the maximum size of the grid, it's going to be 100 by 100.
Okay, 100. Okay, 100 by 100. So if
Mm-hmm.
that's the case, um, okay. So if I'm traversing the whole grid, in worst case it's going to be 10 to the power of 4, but I can have repetitions in somewhere, but I will use a visited state to visit the sets, and then it will expand until it reaches to the destination, right? Okay, so if that's the case, should I proceed to the implementation, or
Yeah, if you feel like that you have already handled all the edge cases, you can.
but give me a minute or two just to analyze it in depth, and I'll be back to you.
Sure, sure, sure.
Okay. Okay, we'll try to process it along the way. So what we're trying to find in here is like um
Maybe let me give you the function definition so
templates.
it could be easy.
Okay.
Let
Yes,
me
it's
give you
gonna be
function
it's
definition.
gonna be much easier. Okay. So first, what we're trying to find is like I want to find the source and the target point. So I'm gonna write source and destination to be none and none. So before that, I have n times m. So let me extract the row and column. So and then okay, and then what do I have is like land at I and j equals to a string of my source. It's going to be my source. So my source is going to be a tuple of I comma j, and if land, okay, so the indentation is not right. So if this is a destination, my destination is going to be I comma j, right? So one thing I want to do, and if source and destination, if I have both of them, I'm gonna break. Let me put this in here, and much easier. Now I've extracted my source and my destination, and now what do I want to do is like fluted cells. So I want to I can extract on this process that the fluided cells, which means all fluided cells initially. So fluided cells is going to be something like this, and I have to remove this. So what I want to check is if land of I was J equals to what's the fluided cell? It's asterisk, right? So if that's the cell, I'm gonna append it into the fluided cell. I comma J. If that's a fluided cell, I'm gonna add it to fluided cells. Okay, and then now what I wanna do is like I want to have the visited asterisk cells only, because okay, so fluided visited cells is gonna be set of this for sure, nothing else, and I'm gonna have a queue, right? So this queue is initially gonna hold on to the cells which are the source. It's gonna hold. It's gonna be the queue, so I have to import that. So from collections port queue, and afterwards, what I wanna do is like in here. What happened? Okay, so what I want to do is like, okay, I have a DQ in here. So what are my initial starting points, right? So I want to put my source in here. And also like, okay, it's going to be source, and then source in a list plus fluided cells also. So this is going to be my starting points, right? So all these points are my starting point, but the starting point that I have, which is a dot and all the asterisks fluided cells, because on every second, all the S is going to expand and all the asterisks is going to expand. So while Q, I want to have the length of the key, because I'm going to do, okay, so I'm going to have a time initially, time, which is at 0, right? So on every next iteration, it's going to be incremented. So len of Q. So for underscore in range. So now I have to pop the cell, right? So around C, Q dot pop left. So I'm removing the cell from the queue, right? And when I remove it, what I do when I check is that if that cell is equivalent to the destination, right? If row call equivalent to the destination, because I have gotten in here. If that's the case, I want to return the time, which is the time I have until this point. So afterwards, I'm going to have a direction array, which is like something like this. It's going to be 1 0 minus 1 0. Okay, 0 1 0 minus 1. Okay, this is my direction array, 1 0 minus 1 0 0 1 0 minus 1. So after this direction array, for I, comma j in pairs, what I want to do is like I want to compute the new row and the new call. So it's going to be r plus I and c plus j, and I have to verify that if less than or equal to new row, this is less than row, and 0 less than or equal to new call, this is less than the call. And so initially I am going in 4 directions for the first S points only. So I have to do something. I have made some mistake in here, right? So on every level, I'm going level by level traversal for both for the S's and also for the fluided cells, right? Right? But I have to differentiate them. I can't make them mix it up, because if the fluided if the cell arrives at that point at the same time the fluided arrive at the same point, it's not going to work out, right? So
Makes
to
sense.
avoid that, to right, so to avoid such a problem, I have to differentiate the queue, right? They have to be in different queues, but I have to traverse them at the same time, right? So what I'm gonna do is source a queue, and I'm gonna fluided queue. So this is gonna be the queue, the same thing. Nothing is gonna be different. So I know I'm gonna have, if there is no fluided queue, right? I'm just gonna traverse only for the path to find whether there is a way or not. So it's gonna be something like this, and the source is gonna be something just like this. So while I have source queue and fluided queue, I want to have both of them, right? So for the first part, what I'm gonna do is for the source queue only. The first is gonna be for the source queue. So okay, source queue, I'm gonna take that row, right? And what I want to check is I know that cell is a dot, which is a source. So what I want to do is, like, I have a land grid, right? So new row. First, it's not in asterisk for sure. I want to make sure it's not included visited cells. So if new row, comma new col, not in. So I have to have actually for stars cells only. So source cells. Also, I'm gonna have a set of which is like this thing, which is source src. So not in these cells, and new row, comma new col, not in source cells, and also it's not fluided, it's not been visited with the dot, and I want to check also the land of new row and new col equivalent to a dot. I want to verify it's a dot, right? If it is a dot, or it can also be a possible scenario, it can also be a D, right? It can also be a D, right? So if this cells in a D, right? So what I want to do is, like, I have source Q, so I want to add it into source Q dot append new row, comma new col. Afterwards, I have I have source visited, right? So source visited cells, source cells dot add. It's okay. So it's gonna be new row, comma new col. So now I have done with expanding the cells, right? And I have to do one more thing. I have to do one more thing in here, because I have to change this cell. I have to change this cell into, like, which is the S, string of S, right? So if it is changed, right, when the flute comes, it's gonna be like an asterisk, right? So when I try to expand from it, okay, so in here I have another scenario I have to handle, right? Because what do I have to handle is, like, I have copied it from the source, but it's already been changed by the fluided queue, right? So I'm gonna do like something like this. Row, comma C equivalent to a string of, like, which is called what's it? It's like, if it is an asterisk, I'm gonna continue, right? So now I'm gonna repeat the same thing, not actually the same thing, but okay. So let's try to fix the indentation problem. Okay, now I have fluided queue. Okay, I'm running out of time, I think. Okay, I'll try to be faster. Okay, so
Try to be calm. It's fine. Try to be
okay,
calm.
okay. So I have fluided queue in here. So I have lengths of fluided queue. So And from flooded queue, I'm gonna pop it. And then if it is an asterisk, I'm not gonna continue. So it's not gonna be a destination, I know, right? So my time is gonna increment only one time in here. Okay, so I'm gonna increment my time in here, time plus equals 1. So what do I have in here for each length? I'm gonna, from flooded, I'm gonna pop it from flooded cells. Now it's gonna expand that cell, right? I know it's flooded. And then when it's flooded, I'm gonna make that new cell into asterisk. I'm gonna change it. So it's gonna be added into flooded cells, flooded visited cells also. Flooded visited cells and flooded visited cells, I'm gonna append it. Okay, so, and also I'm not gonna check in here it's a source because in any way I'm gonna change it. So not, okay, not included cells. And if it is okay, if it is not in, now I went to change it into an asterisk, but it can't be an asterisk, right? So if that row not in source or destination or X, so it cannot be a source, it cannot be a destination, or it cannot be an X. If that's the case, I'm going to add it into the flooded cells and the flooded visited cells also. And then I'm going to make that an asterisk. Okay, so what have I done in here? Let's go over the first example. And okay, and then to traverse level by levels, what if the case scenario is, what if I don't have any kind of flooded cells, right? If I don't have any kind of flooded cells, nothing to do, right? So unless, while I have a source cell, which is I can traverse to, this queue can proceed because it's not going to cause any kind of problem. Because this is important, right? Because I have a source for sure, but I might not have any kind of asterisk. So that's also a possible scenario. So while I have a source, I can proceed. And every time I'm going to increment in my time. So if I haven't reached to any point, I'm going to return -1 at the end of the day. Okay, let's try to go over the code one time. I feel like I have made a lot of mistakes. Okay, let's try to see. Okay, so we have the first example. We have extracted the source and the destination in here. So let's try to be faster. So what's my source in here? Which is like 0, 1, 2, 2, and 1. And I have a destination in here, which is like 0 and 0, right? And I have also extracted this asterisk, which is going to be like flooded. It's going to be something like this, a list of, which is like 0 and 2. Yes. In here I have done this.
We have to try the code, try to finalize, since we have to submit it and check, and we have to move on to the next interview.
Okay.
Try to finalize it.
Okay, so what I'm trying to do is like I'm trying to go over the code with the example and try to see what I've missed. So if I got a bit of a minute, okay, I'll try to finalize it. So I have flooded cells, set of flooded cells, and also source cells in here with the source, and I have a source queue and a flooded queue, right? Both of them. So I have this directional array for all of them, and starting at for the first, if source and destination is the same, the time is going to be this. The time is going to be like 0. So I have a length of the queue, which is like the source queue. So for each length, I have taken from the source queue, and if that's an asterisk, I'm not going to do anything with this because it's not the source that I want to play with. So moving forward, what I'm going to do is like if R, if it is a destination, I'm going to return my time. Okay, and then for each direction, I'm going to compute the new array, and I will check whether it is not in range, and it's not included cells. Also, it's not in the source cells because it's a new cell to navigate, and it can be one of the dots or a D, right? And then if that's the case, I'm going to add it into the source, append it into the visited cells, and then I'll mark that cell as S. Right. So
sorry to interrupt, but we're over on time, so we have to check it. Are you ready?
Okay. Okay. Let's
right. Share my screen. Let's share. This is actually the code I have written preparing for this interview. I'm going to paste the code that you have written. I think there is some indentation problem.
It's an indentation issue, I think.
Yeah. Okay, what else? What else we need to fix? I think this looks fine, right? I should run it. Oh, this Premiere account. So I'm going to do this. Why is it asking me to sign in?
Bruke.
Yes.
Can I just remove this first line that I'm making an S? I think this is not important in the first loop. I can't make it an S because like it's the I only need the original S and the rest cannot be changed. So can I remove it? I have removed it. Yeah.
All right.
Just okay. Because that's going to cause a problem.
Okay, I think we're back. Let me just paste your new code. All right. Do we have any other indentation issues? All right, let's run it. I think we have some object here.
Typo. I think it's typo.
Is it typo?
What's the problem? Fluid. Okay.
I think you're trying to append
into fluid cells. Yes.
Okay.
Fluid, not visited. It's fluid cells only.
Right,
Just
I'm trying to submit it.
Oh, it's not okay. Hold on. Okay, it wasn't like that. Okay.
Brush.
Okay.
Since
First,
we have
no.
to continue.
Fluid visited cells. You type. You change it into fluid cells. You added. You make both of them and add. It should be an append. The one you fix the problem. That's why it's
It
just
was an append. It is supposed to be an
not,
append.
It's an append, but it's not fluid visited cells. It is fluid cells. You can copy it from the above. It's fluid cells. That's why. It's not fluid visited cells. That's the problem.
This one.
Yes.
I'm giving you the benefit of the doubt. Right.
Isn't it like that? Yes, fluid Q. I'm sorry, it's not fluid cells. Fluid Q. If you see above, it's fluid Q. There is no fluid cells in definition because I'm traversing along the Q, right? So it's fluid Q. It's my bad. It's fluid Q. Yes.
All right. This is successfully submitted. Thanks, Brush. I have to move on to the next interview.
Thank you.
Over here, just unpin this. All right, so let's start with introduction, Nardos.
Okay. Do you want me to introduce myself?
Yes.
Okay. My name is Nardos. I was group 46 student. Now I'm group 5 in personal of education.
Right. Thank you.
Okay.
So I'm going to send you the link to SharePad. Okay. Paste it here. Go to the link and check if you can edit it. Then I'll paste in the question.
Okay.
Have we found the SharePoint link?
Yeah.
Let's check if you can edit it.
I'm just saying print hello world.
Yeah, like can you edit the text? Try to edit it. All right, that's what I need. Right.
Okay, shall I start?
Yes, go ahead.
Okay, the question says you are given by M, the index stone sentences. Yeah, 200 empty stone. This is uploaded. Okay, at each second, you can move a cell that shares a side with and you can move a cell that shares a side with your current cell. That means for cardinal direction. Also, at each second, every empty cell that shares a side with floor cell become flooded as well. Okay, there are two problems ahead of your journey. You can step on stone cells, you can step on floor cells. Since step on the floor cells, since you're wrong, so you can step. I say that will be flooded. Okay. Nice. Okay. Hello. Hello.
Yes.
Okay, I think the question says there is a cell in the biome set, and there are empty cells and cells with stone and cells with cells. So those are flooded. So every time in every second, the cells, empty cells that are neighbor to the flooded cell will become flooded as well. So, but we at the start we are at the position S, so we need to get to the position D only passing through the empty cells, not the flooded one or not the stone. So, what is the minimum time it takes to reach the destination? I think that's the question. If it's not possible, we return -1. So, so my approach is, I think it's an obvious question. I mean, it's a typical question for BFS, I think. So what I'm going to do is I start my BFS from the start S, and every time the start end, my flood, the flooding, there will be two BFS, two BFS, two BFS. So there will be a flood, and there will be my movement. So every time, since here we can step on the cell that will be flooded at the same time as we step in. So I will first give the priority for the flooding, then I will move to that cell. So in that way, I think it will be solved using the FS.
So, like, are there any edge case you would like to consider, or you're confident with your solution? You can move on to implementation.
Okay, can you give me the constraints on the inputs N and M?
The maximum size for N and M is going to be 100.
100 both?
Yes, 100.
Okay. Mm, yeah, I think there should not be an edge case. As yeah, there should not be an edge case. This is it.
All right. I will copy paste the function definition, so it could be easier when we submit,
Okay.
and you can start implementation.
Okay. And also, are there any examples to make the question clear? Okay, thanks.
So to make it more readable, I guess it's better if we do it like this.
Yeah. Okay, it's clear. I'm waiting for you to paste the template for the starting code. Okay, thanks. So, shall I start implementing it?
You can start.
N will be the number. Let's call them house. House will be the length of land. This will be length of land. And also yes. Okay. So for are in a range of info. So if land fix extension before so they will be visited. Be false times. So yes. So yeah. Okay, so I'm going to always move them. Yeah. I think yeah. There should not be an education. Oh, sorry about this, but how is it the example? The example's answer is 3.
Uh, so you can start the progress of the source from here, and in the first second, this part is going to be flooded, right?
Yeah,
And so this part.
yeah.
And
Oh,
in the first second, our star could go here.
yeah. I see. Yeah, sorry about
Uh,
this. I thought
you get it?
yeah, I thought that there will be a diagonal move. Yeah, I get it. Thank you. It's obvious. think this solve it.
All right. So
Do you want me to explain the code?
like if you want to maybe have a dry run on it, since you have a few minutes, you can do that. Then we'll test it.
Sorry, I didn't hear you well.
If you want to have a dry run on your code and test it with the given example case or whatever you want to do, since you have the time,
Okay.
just double check.
Okay. So can I check? Okay. Let's check it on the example.
Okay. I think the next, if you check it like going on your code manually,
Okay.
not just by running it.
Okay. What? What happened here? Oh, here it should be here. Okay. Links.
Okay, Nardos.
Okay.
You have been quiet for a while.
Okay. Yeah, I think this is it. You, sorry, I didn't get your point. You were saying explain it or debug it?
I think are you checking your own like your code? Having
Yeah,
a drawer?
I thought you said that.
All right, all right. I was waiting for that. Since we have, I think, 4 minutes now, let's talk about the complexity.
Okay.
And it
Um,
would be nice to hear like time complexity, like complexity analysis coming from the interviewer for the future
okay.
sake.
Okay, I think since it's a DFS, it will be of n times m, uh, because I'm only visiting points only one time. Since here I didn't use the visited, but if it's required to not modify the given list of list, the given land, I can use the visited list of list. But in order to minimize in order to simplify the code, also to minimize the space usage, I used the given list of list itself to make it's visited. How I know it's visited, I will change the empty lands, empty cells with the asterisk. So that means if it's asterisk, it means it's been already visited. That's how I implemented it. So the time
What will be
complexity,
the space complexity because you have done that?
yeah, because I've done that, it will be actually the time complexity, the space complexity will not change because still there is a queue. In our queue, in worst case, we might take every cell, so that would be n times m.
Mhm.
So both space and the time complexity will be n times m.
Right. Thank you, Nardos. Right. So, like, should I move on and submit the code?
Yeah, I think so. Yeah.
Okay. Let me share my screen so you can see it as well.
Okay. So should I stop presenting?
It's fine. It's fine since it's going to be visible. Okay. Okay. Let's try to run it. Hmm. We have a wrong answer.
Oh, okay. Can I debug it or what I'm gonna do?
Try to find the bug that's creating this in your solution.
Okay.
Like, go
Sorry.
ahead and check your code basically.
Okay, can I see the test case? I think it's not really visible.
It's the first test case.
Okay, the first test case. Okay. Hmm. No, I think. Can I run it or
Mm-hmm.
can I run it here over?
Have you fixed the code?
No, I to know the again. I think. Um, oh, I think. Oh no. One minute.
Nardos, we're on time constraint, so
Okay. Uh,
okay.
Sorry, I don't.
Yeah. Since time is up, we'll be forced to conclude here. Thank you for your time, Nardos.